In this video, we'll learn how to estimate the Probit model under the assumption that the deterministic utility is a linear function of the attributes. The multinomial Probit model defines the probability of taking alternative k in this equation, and it actually comes from the probability that the maximization of zj is always smaller than 0. Here zj is defined as uj prime minus uk, and it could be written into the vector format. And we also define zj minus 1 as the maximization of z1, z2, z3 till we get a zj minus 1. By Clark's approximation, we can find that zj minus 1 tilde is a normal distribution with the mean mj minus 1 tilde and the variance sigma j minus 1 tilde. And these two parameters will be applied in this equation to estimate the probability of taking alternative k. In addition, we assume that there exists a linear relationship between the deterministic utility and the attributes x. Here, theta represents the coefficients applied for each attribute. For the multinomial Probit model, we have several assumptions. First, the utility consists of the deterministic component and the random component. Vn is the deterministic component, and it could be represented as the linear function of the attributes. Also, the random term xi is a multivariate normal distribution with the mean 0 and the covariance matrix sigma xi. Here, the covariance matrix is a J by J matrix. We also define the variable z, which will be the differences between utilities, and this one can actually be divided into two components. The differences between the deterministic utility and the difference between the random term. Also can simplify the relationship between z and the utility into matrix format. Here z prime equals to u times a transformation matrix, and the size of the transformation matrix is j by j minus 1. Here we use delta to represent the transformation matrix. And then we can estimate the mean of the variable z, which will be the deterministic component. It will be the deterministic utility times the transformation matrix. That would be v prime times delta. The covariance matrix of z can be estimated by this equation, that is delta prime times sigma xi times delta. And we know that the size of the transformation matrix is j minus 1 by j. Then we can quickly find out that the size of the covariance matrix of z is j minus 1 by j minus 1. With this, we get the covariance matrix and mean for the variable z. Now we will record the Clark's approximation to complete the model estimation. Previously, we defined that omega I tilde as the maximizing omega I minus 1 tilde and omega I, which is also the maximizing of I random variable from omega 1 to omega I. We say that omega I tilde is also in a normal distribution with the mean mi tilde and the variance sigma I tilde. We have the expressions about the mean and the variance. Then we can apply this approximation for the scenarios we are considering here. Here we have j minus 1 z values. We will start from the first two random variable z1 and z2. Let z2 tilde as maximizing of z1 and z2. Then we say that z2 tilde is also in a normal distribution with the mean of m2 tilde and sigma 2 tilde, and we have the expression for m2 tilde and sigma 2 tilde. Also, we can derive the covariance sigma 2 3 tilde. And next step, we will estimate the maximization of the first three random variables z1, z2, z3, which is also a maximizing of z2 tilde and z3. We define the maximization is Z2 3 tilde, and it follows the normal distribution with the mean of M3 tilde and sigma 3 tilde. Here are the expressions to estimate M3 tilde and sigma 3 tilde, and also we can get the covariance of sigma 3 4 tilde. Um, in these expressions, we also have the values of M2 tilde and sigma 2 tilde, and those parameters are estimated from the first step. So we will call the formulas we estimated previously and applied in these equations. We will have an extended expression for M3 tilde, sigma 3 tilde, and sigma 3 4 tilde. This step can be iterated for a lot of times until we reach to zj minus 1 tilde. So eventually we will get the probability of taking alternative k as phi minus mj minus 1 tilde over sigma j minus 1 tilde. Here mj minus tilde is the mean of the variable zj minus 1 tilde, and sigma j minus tilde is the variance. From the previous analysis, we can find that this probability is also a function of theta and sigma psi. Here, theta is the coefficients applied for the attributes. Assuming that there are p attributes, then we need to define p plus 1 coefficients. The first one, theta 0, is defined for the constant term. In addition, we have the covariance matrix for the random term. The size of the matrix is j by j. In that sense, for the covariance matrix, we have j times j plus 1 over 2 unknown parameters, and there are p plus 1 unknown coefficients. Totally, we have p plus 1 plus j times j plus 1 over 2 unknown parameters to estimate for the Probit model. In order to estimate the parameters, we need to call the likelihood function. So first we will form the likelihood function for the n observations in the sample, and then the model estimation will try to maximize the likelihood function. Here you will find that the function f is not a differentiable function, so it's impossible for us to find out the analytical solution. Then we have to call some heuristic algorithms or some other searching techniques to find out the values of theta and sigma psi. The heuristic algorithms are very common for us to complete the Probit model estimation. There are actually some typical input data for heuristic algorithms. First, we have to know how many observations we have for the model estimation, and we need to specify the number of the alternatives, parameters, and attributes. Second, for each parameter, in this case, there will be the coefficient theta and the covariance gamma. We have to specify the minimum and the maximum values, and also for the heuristic method, we need to find out the initial guess for each parameter. And third, we have to know the data set. That will be the value for each individual. In this case, we have to know the value of the observed attributes and also the observed choice for each individual. And finally, we need to specify the formulas for the deterministic components and the format of the covariance. For the Probit model, we assume that the deterministic component is the linear function of the attribute, and the covariance matrix is a symmetric matrix. Now let's see how we can apply the heuristic algorithm to complete the Probit model estimation. In the example, we'll consider three alternatives: bus, trolley, and auto. Also, we assume that the deterministic utility is a linear function of travel time and cost, so that is Vi equal to theta 1 Ti plus theta 2 Ci, and it's applied for all the three modes. In addition, we assume that the bus and trolley share neglect attribute, which means they're going to share the unobserved attribute, but they won't affect the auto, which means auto is totally independent to bus and trolley. Then with these assumptions, we can make a reasonable specification for the covariance. That would be sigma psi is 1 gamma 0 gamma 1 0 0 0 1. So the covariance between bus and trolley is gamma, but auto is totally independent to bus and trolley. In the multinomial Probit model, we need to ensure that the covariance matrix is valid, which means it has to be positive definite. So we need to make sure that the determinant of the covariance matrix be positive. That means we will have 1 minus gamma square higher than 0, which will give you the range for gamma. Absolute value of gamma should be less than 1. In the heuristic algorithm, we need to specify the ranges and initial guess for each parameter. For this example, we have to specify the ranges for 3 parameters, theta 1, theta 2, and gamma. We know that the range of the gamma is between minus 1 and 1, so we specify the minimum value is minus 0.99 and maximum is 0.99. And for theta 1 and theta 2, the range should come from the previous study or some human experience. Say that we can specify the range from minus 100 to 0. The initial guess is very tricky. You can either specify any value between the minimum and maximum values, or you can choose the boundary. And with the selected boundaries and the initial guess, you can apply the Clark's approximation to do the model estimation and complete the iteration again and again to find out the true value of the 3 parameters. So that's all about the chapter 4, this grid choice model. For now, we have finished all the lectures in this class, and you have done very great job. To review the course, I highly recommend to go through all the course notes carefully. It will be very useful for you to understand the fundamental concept in transform planning.